Before DDR existed, your computer used something called SDRAM. This was the late 90s. Windows 98, Pentium 3 processors, and RAM that moved data like molasses. One piece of data per clock tick. That's it. Your RAM ran at maybe 100 megahertz, and everything felt slow because your processor was sprinting while your memory was crawling. It was like a single-lane road where only one car could pass at a time. Then the year 2000 happened, and DDR1 changed everything. This was flip phone era. Napster was getting sued and everyone panicking over Y2K. And engineers looked at RAM and asked a simple question. Why send data once per clock tick when we can send it twice? They called it double pumping. Your clock signal goes up, then down. That's 2 moments. Old RAM only used the up part. DDR1 used both. Boom, double the speed without making anything actually run faster. It's like suddenly having a 2-lane road where cars can pass going both directions. But DDR1 was power hungry. It used 2.5 volts, which by today's standards is like leaving your oven on all day. And the speeds topped out around 400 megatransfers per second. Your phone's RAM today is literally 20 times faster than that. But in 2000, if you had a PC with DDR1, you were living in the future. Back then, a single gigabyte of this stuff could cost you over $100. Today, you can buy 16 gigabytes for less than that. Then in 2003, DDR2 showed up, right when iPods and MySpace were taking over. The promise was simple: twice the speed, half the power. Voltage dropped to 1.8 volts, your electric bill relaxed a bit, and speeds jumped to 1,066 megatransfers per second. They moved some components from your motherboard directly onto the RAM stick itself. Think of it like moving a traffic light from the highway entrance directly into each car. Way less confusion, way cleaner signals. But the weird thing is, DDR2 was not always faster than DDR1. For quick tasks, DDR1 sometimes felt snappier. For heavy workloads like running tons of browser tabs, DDR2 crushed it. People argued about this online for years. Some thought DDR2 was a total waste of money. Others couldn't understand why anyone would stick with DDR1. Turns out both groups were right. It just depended on your workload. By the time everyone figured this out, the RAM world was about to change again. DDR3 launched in 2007 and became a legend. This was iPhone launch year. Facebook was taking over college campuses, and DDR3 became the RAM that an entire generation of gamers used. It dropped power usage again to 1.5 volts, and even lower to 1.35 volts for laptops. Speeds went all the way up to 2,133 megatransfers per second. And here's the crazy part. It lasted almost a decade. If you built a gaming PC anytime between 2010 and 2015, you probably used DDR3. This was the RAM that powered the cloud computing boom. Every data center building the backbone of the internet used DDR3. It was reliable, it was cheap, it was the Honda Civic of memory. Not flashy, but it got the job done for years without complaining. By 2025, you can still find this stuff for pocket change, around $25 for a decent amount. Perfect if you're building a retro gaming setup or fixing an old office computer. Fast forward to 2014, DDR4 arrived, but nobody cared at first. It launched expensive and barely faster than DDR3. Early adopters paid premium prices for minimal gains. Reviewers called it unnecessary. Gamers ignored it completely. Why upgrade when DDR3 was still perfectly fine? Then something interesting happened. DDR4 organized memory into bank groups. Think of it like this. DDR3 was a single checkout line at the grocery store. DDR4 opened multiple checkout lines. Your computer could bounce between different groups and get way more done at once. It's the difference between everyone standing in one massive line versus having 5 lines running simultaneously. Parallelism, doing multiple things at the same time without waiting around. This is why Chrome with 47 tabs stopped freezing your entire computer. Voltage dropped to 1.2 volts. Speeds started at 1600 and climbed to 3200, then kept going past 4000 for the enthusiast crowd. And here's the secret about DDR4. It became the overclocker's dream. The way manufacturers laid out the circuits on motherboards meant if you only installed 2 sticks of RAM in the right slots, you could push insane speeds. That's why every overclocking guide tells you to use specific slots. It's not superstition, it's just physics. And in 2025, it's still the most popular RAM type for most people. You can grab 16 gigabytes for around $40 to $50 right now. It handles gaming at 1080p and 1440p without breaking a sweat. It runs productivity software smoothly. It's still the sweet spot for price versus performance. Year 2020 changed everything with DDR5. It wasn't just an upgrade, it was a revolution. DDR5 looked at how DDR4 worked and said, the problem is the traffic jam. See, DDR4 had one 64-bit wide highway for data. DDR5 split that into two 32-bit highways running side by side, each one independent, each one handling its own traffic. What does that actually mean? If you've got a modern CPU with 16 or 24 cores all screaming for data at once, DDR5 can handle twice as many requests simultaneously. If you're running a dual-channel system with 2 sticks, you're effectively managing 4 independent lanes of traffic. And here's the craziest part. This stick of RAM is smarter than your 2015 laptop. It has its own power supply, its own error correction, and it's literally processing signals like a miniature computer inside your computer. This means cleaner power, less electrical interference, and the ability to run way faster. DDR5 starts at 4,800 megatransfers per second. High-end kits are hitting 9,600 right now in late 2025. Some special modules called CUDIMMs are pushing toward 10,000. Now here's where people get confused. Every DDR5 stick says it has ECC on the box. People see that and think, oh cool, error correction like servers use. Not exactly. It protects your data while it's inside the chip itself, but it doesn't protect data while it's traveling from the RAM to your CPU. And for the first time, you can buy 48 or 24 gigabyte DDR5 sticks instead of 32 or 64. This is because DDR5 supports memory chip sizes that aren't perfect powers of 2. It's unusual, but it means you can build a 96 gigabyte system without paying the insane price for 128 gigabytes. And speaking of insane prices, here's the plot twist. The RAM market in 2025 isn't controlled by gamers anymore. It's controlled by artificial intelligence. There's a different type of memory called high bandwidth memory, HBM for short, that AI training computers desperately need. These stacks move over a terabyte of data per second. Every AI data center needs them. So manufacturers have pivoted production from standard DDR5 to HBM because the margins are absolutely insane. This led to a DDR5 shortage, and in late 2025, server DRAM prices spiked 20 to 30%. You are effectively paying an AI tax on your consumer RAM because the factories are busy building chips for data centers. For building new in 2025, expect $80 to $120 for a decent 16 gigabyte kit. Not cheap, but reasonable for cutting-edge tech. However, the industry is already planning for the next technological leap. DDR6 will launch probably around 2027, and it's using a completely different signaling method that doubles speed but adds complexity. Think of it like switching from AM radio to digital streaming. More data, but way more processing needed. So if you're building a PC today, DDR5 is the move, but don't overspend on the highest speed bins, unless you've got a specific workload that needs it. If you're still on DDR4, you're fine for most tasks. Seriously, a well-tuned DDR4 3200 kit still holds up. And if you're waiting for DDR6 to build your next rig, you're going to be waiting until at least 2027. And even then, early adopter pricing is going to hurt. However, the RAM in your system is smarter, faster, and more sophisticated than you probably realize. It's not just storage. It's the bridge between your CPU's hunger for data and the reality of physics trying to slow everything down. Now you know the full story, from the slow, single-lane highway of SDR all the way to the complex, intelligent, multi-lane system of DDR5. Every generation solved a problem, every generation made trade-offs, and every generation pushed the limits of what physics said was possible. DDR1 said, use both edges of the clock. DDR5 said, split the highway in two. DDR6 will say something even crazier. And your PC? It just wants to go fast. Now, you know how to help it. Thank you for watching, and see you in the next one.